Welcome back, everyone. Okay, let's just dive right into this. In today's explainer, we're going to completely demystify the core architecture of MQL5 trading automation. If you've ever found yourself sitting there wondering exactly what happens under the hood when your code decides it's time to buy or sell, well, you are in the exact right place. We're breaking down the literal anatomy of an algorithmic trade. We're going to take you all the way from top-level software concepts straight down to the exact data structures and server responses that make automated trading tick.
So here's our macro to micro roadmap for today. First, MQL5 trading programs. Second, market data structures. Third, we'll untangle orders, deals, and positions. Fourth, executing trade requests. And finally, number 5, tracking the trade transaction lifecycle. Simple enough, right? Let's get to it.
Starting off with Section 1, MQL5 trading programs. Basically, who are the active actors in our automated system? All right, in the MQL5 ecosystem, the absolute premier automated system is the Expert Advisor, or EA. An EA is essentially an automated trading system linked directly to your chart. But what makes it so incredibly powerful is its unique ability to handle predefined market events. Think about it like this. When a new price tick comes in, an event literally called new tick, your EA catches it, runs your custom algorithmic logic, and can automatically fire off trade requests straight to the trading server. It is, without a doubt, the active brain of your entire operation. Now, when you stack EAs up against custom indicators and scripts, a pretty clear hierarchy emerges. Just look at the event handling differences here. Indicators are built strictly for analytical functions, right? And scripts, they just fire off a single action on command and then stop. But the EA is designed to constantly listen to the market via events like on-tick and on-trade and react by automatically trading. Your choice of program dictates what you can actually build. So if you want full hands-free automation, the EA, which lives in your Experts folder, is absolutely your go-to tool.
Moving on to Section 2, Market Data Structures. How do our automated programs actually perceive the live market?
Okay, so your EA looks at price through two completely different lenses, MQL tick and MQL rates. If you want to build a historical signal analyzer, say calculating a moving average over the last 50 candles, you're going to need MQL rates. That gives you the open, high, low, close, and volume for a specific time frame. It's the history book. But for lightning-fast execution right now, you have to pull current prices using MQL tick. This structure grabs the exact bid, ask, and last deal price for this literal millisecond. Section 3. Orders, deals, and positions. This is the semantic core of MQL5, and honestly, it's often the biggest barrier to entry for developers coming over from languages like Python. Let's actually see how this builds across the timeline. Notice the logical flow here, from a request to an action to the final financial result. At time 0, you submit an order. A tiny fraction of a second later, the broker executes a deal. And the result of that deal? That's your position. You make a request, the broker acts on it, and you're left with a market commitment. Let's drill down into each of these, starting with orders. Simply put, an order is just a request sent to your broker to execute a trade operation. Frame this in your mind as the initial digital requisition form, right? It hasn't made you a single cent yet. It's literally just you telling the broker, hey, I want to buy one lot of Euro USD at this price. That request can be sitting active as a pending order, or it can be historical if it was already completed or canceled. Next up is the deal. A deal is the reflection of the fact that a trade operation was executed based on your order. You can really just think of the deal as your receipt. It's returned to the trader confirming that the action actually physically happened. Your order was the request. The deal is the undeniable proof that your broker actually filled it. And finally, we have the position. A position is the ongoing market commitment, either long or short, that is formed as a direct result of those executed deals. This is your current live financial state in the market. And what's really crucial to note here is that if you're using a hedging account system, you can actually hold multiple completely opposite positions on a single symbol at the exact same time. Pretty wild, right?
Okay, Section 4, Executing Trade Requests. Now, before we actually pull the trigger here, remember that professional architecture demands data persistence. We've got to align our trade execution with professional SQL database management, adopting a strict prepare, bind, and step workflow for our local databases right alongside our trade orders.
Executing the trade itself is a very strict three-step process. First, you populate a structure called MQL trade request with all your specific trade parameters.
Second, you push that request off to the trade server using the order send function. And third, you catch the server's reply in a separate structure called MQL trade result. Basically, the request structure is your input, the result structure catches your output, and order send is the vehicle moving data between them.
Stripping away all the noise, these right here are the absolutely mandatory fields you have to populate in your MQL trade request to execute a basic market order. You got to tell the server the action you want, the symbol you're trading, the volume, the direction type like buy or sell, and the filling policy. If you miss even one of these, your order send function will fail before it even reaches the server. No way around it.
Which brings us to Section 5, the Trade Transaction Lifecycle, tracking the aftermath of your trade.
So, here's a critical question for you. You fired off the order send function, but how does your expert advisor actually know if an order was filled in the real world? The secret lies in the asynchronous nature of one specific event handler.
As the trade server processes your request, it sends a stream of transactional updates right back to your terminal. Your EA catches these updates using the on-trade transaction handler. By analyzing the MQL trade transaction structure that gets passed into this handler, your program knows exactly what the server is doing with your money at any given millisecond.
As your trade progresses, the server is firing these different transaction types straight into your terminal's queue. First, you might see an order add transaction, meaning the order was created. Then a deal add, meaning execution actually happened. This is usually followed by history add and a position change transaction. These granular updates are essentially telling your EA exactly how the order is progressing in real time, step by step.
But wait, here is a massive technical warning you cannot ignore. 24. That number is exactly how long your terminal's transaction queue is. It maxes out at 24 elements. If your expert advisor code is heavy, or let's say it blocks the thread for too long while calculating something else, that queue is going to fill up fast, and the terminal will start overwriting your oldest unread transactions. You could literally miss the notification that your trade was executed. It's a real game changer if you're not careful.
So, the absolutely crucial point to remember is this. A single trade request sent to the server can generate several new transactions, and the priority of their arrival is not guaranteed. Listen, just because you sent one request does not mean you're going to get a guaranteed, perfectly sequential set of execution notifications. You have to code your expert advisor defensively so it can handle these events whenever and in whatever random order they happen to arrive.
Which leaves us with this provocative thought to wrap up today's explainer. If a single trade request triggers a chaotic, totally asynchronous cascade of disconnected orders, deals, and position changes, is your code robust enough to survive a live market? And just as importantly, are you successfully persisting all that chaotic data into your local history using the database API's prepare, bind, and step workflow we touched on earlier? Because honestly, marrying flawless asynchronous execution with professional SQL management, that is exactly what separates the novices from the pros. Thank you so much for joining me on this deep dive into MQL5, and keep learning.